friends, you are welcome to your favorite learning channel. We are still on velocity time graph. Today we'll be deriving another velocity time graph from word problem. So let's get right into the class. The question says that a car runs at a constant speed of 15 meters per second for 300 seconds and then accelerates uniformly to a speed of 25 meters per second over a period of 20 seconds. This speed is maintained for 300 seconds before the car is brought to rest with uniform deceleration in 30 seconds. Draw a velocity time graph to represent the journey described. From the graph, find Roman figure 1 the acceleration while the velocity changes from 15 meters per second to 25 meters per second. 2. The total distance traveled. Then 3. The average speed over the time described. Now, to draw a velocity time graph from word problem, the first step that you need to take is to draw your velocity axis and your time taking axis. So your velocity axis will be on the vertical line, then your time taking axis will be on the horizontal line. So let's do that first. Our velocity axis on the vertical line. So this is our velocity axis in what? In meter per seconds. Then your time taking axis on the horizontal line. So time is in what? Is in seconds. That is the first step to take. Now let's follow our instruction. Now let's follow the question. So it says that a car runs at a constant speed of 15 meters per second. A car runs at a constant speed of 15 meters per second. Then speed is the same thing as velocity. So on the velocity axis, a car runs at what? 15 meters per second for 300 seconds. So 15 meters per second is our velocity for 300 seconds. So you first locate 15 meters per second on your velocity axis. So let's assume that this place is 15. Let's assume that this place is 15. Then the car travel for what? For 300 seconds at this 15 meters per second. At this 15 meters per second. So it travels for 300 seconds. So we are going to trace it to what? The time taking axis. So we trace it to the time taking axis. So this is 300 seconds for 300 seconds. Now let's read further. And then accelerates uniformly to a speed of 25 meters per second. Accelerates means that it travels up. Then don't forget that I explained in my last video that when an object accelerates on velocity time graph, it will go in a slanting form. It will go in a slanting form. So let's read the question again. And then accelerates uniformly to a speed of 25 meters per second. So at this point where it stopped, then it will accelerate. It's accelerated to what? To a speed of 25 meters per second. Your speed is the same thing as velocity. So at this point, this is what? 25 meters per second. This is 25 meters per second. So at a speed of 25 meters per second, so we have located our 25 meters per seconds over a period of 20 seconds. So it's accelerated at what? At 20 seconds. So we are going to trace this point down. We are going to trace this point down. So this is 20 seconds. So from here down to this place is 20 seconds. So we are going to add 20 to 300. It will give us 320. So this point is 320 now. Then let's read further. This speed is maintained. So it's now maintained this speed for another 300 seconds. So it travels further for another 300 seconds. For another 300 seconds. So the next 300, now we are going to add that 300 to 320. It will give us 620. 620. Now, it travels, it maintains the speed for another 300 seconds. So we have done that. Then before the car is brought to rest, with uniform deceleration. Deceleration means going down. So it travels down in what? In 30 seconds. It's brought to rest in what? In the next 30 seconds. So we are going to add 30 seconds to 620 seconds. It will give us 650 seconds. So this is the graph. So draw a velocity time graph to represent the journey described. So we have done that. So we have formed our velocity time graph. So from the graph, Roman figure 1, find the acceleration while the velocity changes from 15 to 25 meters per second. We are looking for acceleration. Acceleration is A, where the velocity changes from 15 to 25 meters per second. So we are going to locate the point where the velocity changes from 15 to 25 meters per second. So this is 15. So from this point down to this point is where the velocity changes from 15 to what? To 25 seconds. So let's trace it down to this place. From here down to this place, that is where the velocity changes from 15 to 25 meters per second. So we have formed what? A triangle. So we are going to use this triangle to calculate our acceleration. Then don't forget that our acceleration is equal to what? Change in velocity divided by the time taken. That is the formula for calculating acceleration. Acceleration is change in velocity divided by the time taken. So your V will be the final velocity. It will be the final velocity, while U is your initial velocity divided by the time taken. So what is our final velocity? Let's locate these points now. Within 15 to 25, because our question says that find the acceleration while the velocity changes from 15 to 25 meters per second. So our attention will be focused on where the car accelerated from 15 to 25 meters per second. So within this triangle. So now, what will be our final velocity? So this is the starting point. 15 will be our starting point. Then 25 will be our what? Our end point, which is the final velocity. So 25 is our final velocity if I trace it down to this place. So our final velocity is equal to 25 minus the starting point is 15, our initial velocity, divided by the time taken. So the time taken within that what? 15 meters per second to 25 meters per second. What will be the time taken from the starting point is 15 now, which is 300. The time taken is 300 to 25 meters per second. So the time taken for that is what? Is 320. It should be 320 minus 300. So 320 minus 300. So our acceleration will now be equal to 25 minus 15 will give us 10. Divided by 320 minus 300 will give us 20. So 0 cancel 0. So 1.5, that will be 0.5. So 1.5 equal to 0.5. Then what are we looking for acceleration? The unit is what? Is a meter per second square. So we've gotten our answer for the first question. So Roman figure 2. Calculate the total distance traveled. So to calculate the total distance on velocity time graph, you use the shape that appear on the graph. So the shape that appear on the graph is equivalent to the total distance traveled. Total distance traveled is equivalent to the shape that appear on the diagram. So let's solve Roman figure 2. Total distance is equal to area of the shapes. area of the shapes. Then let's look at the shape that we have on this graph. Let's look at the shape that we have on this graph. The first one, from here down to this place, is a rectangle. This is a rectangle. We have a rectangle. Let's call it a shape A. Then the one at the middle is a trapezium. Let's call it shape B. So this one is a rectangle. This is another rectangle. Let's call it shape C. Then this is a triangle. Let's call it shape D. So it will be the area of a rectangle plus the area of a trapezium plus the area of a rectangle plus the area of a triangle. So that is the shapes that appear. Those are the shapes that appear on the graph. Those are the shapes that appear on the graph. So your total distance now, total distance equal to area of a rectangle. What is the area of a rectangle? That will be length, let's say area of A plus area of A plus B plus area of C plus the area of D. Then what is the area of A? Our A is a rectangle. That will be length times breadth. Formula for calculating area of a rectangle is length times breadth plus the area of a trapezium. That is 1/2 into bracket A plus B times height plus the area of a rectangle C. The area of a rectangle C, that is plus length times breadth plus the area of a triangle 1/2 times base times height plus 1/2 times base times height. That is half base times height. So which is equal to the length. What is the length of this rectangle? The length is what? The length is 15 to 0. That is 15. So we have 15 times, from here down to this place is 300. So 300, the length is 300 multiplied by the breadth. So that is 300 times 15 plus, so the area of a trapezium, that is 1/2 into bracket the first parallel line and the second parallel line. So this is our first parallel line. This is the second parallel line on this trapezium. So what is the length of this parallel line? From here down to this place is 15. So that is 15 plus the length of the second parallel line is what? Is 25 plus 25. Then times the height of this trapezium. The height is from here down to this place. This is the height. So the height is from 300 to 320. So 300 minus 320 will give us 20. Then plus the length of the rectangle. The length of this rectangle is from 320 to 620. So 320 to 600, that will be 620 minus 320 will give us 300. That is 300 times the breadth of this rectangle is 25. That is this side. This side is 25. Then plus half the base of our rectangle. This is the base of this, the base of the triangle. This is the base of our triangle from 650 to 620. That will be 650 minus 620 will give us 30. Then multiply by the height. The height of the triangle is from here down to this place. That is 25. Multiply by 25. Now 300 times 15 will give us 4,500 plus 2 here 1, 2 in 20 will give us 10. 15 plus 25 will give us 40. So 40 times 10 will give us 400. Then plus 300 times 25. will give us 7,500 plus 7,500, then plus 2 here 1, 2 in 30 will give us 15. 15 times 25 will give us 375. 375. So by the time we add everything together, we are going to arrive at 12,775. 12,775. So 12,775 is our total distance. Is the total distance, that is the total area of the shape that appear on this diagram. Then the total distance is in what? What is the unit? Is in meter. So Roman figure 3. Roman figure 3. The average speed over the time described. We are looking for the average speed. So speed equal to the total distance divided by the total time taken. Total time taken. So total distance divided by the time taken. Then we have gotten our total distance from Roman figure 2. So our total distance is equal to 12,775 divided by the total time taken. So we come to the graph. 650 is our final time taken. So that is our total time taken. So our time taken is equal to 650. So 12,775 divided by 650 will give us 19.65. So 19.65 what? Our speed is in what? Is in meter per second. So 19.65 meter per second. Taken. The average speed over the time taken is 19.65 meter per second. So we have come to the end of this class. If you are watching me on TikTok, kindly click on the link in my bio. It will take you to my YouTube channel. That is Royal Learning Channel on YouTube. Then don't forget to share, like, and leave comments. See you in my next video. Bye.